Hi, Year 7. I hope you've enjoyed the lessons on sound that you've done so far, lessons 1 and 2. This is lesson 3, and we've got 5 learning objectives. We need to learn how the ear detects sound, and how we measure loudness and pitch, and how we can damage our hearing. It's especially important for people of your age. And then how a loudspeaker works. The way a loudspeaker works is very similar to how the ear works, because they both detect sound. On this slide, we can see all the parts of a human ear, including those which are inside your skull. I'm not going to go through the parts of the ear, but I do want you to draw this picture in your books and to label it, and then to write a sentence about what each part of the ear does. Also, if you click through the actual PowerPoint and open the links on the left, then that will give you a lot more information and help you revise how the ear works.
In this video I want to talk about the parts of the ear and how they work. First of all, the sound is collected by the outer ear, which is called the pinna, and it travels down the auditory canal to the eardrum, and the eardrum is then caused to vibrate, and those vibrations transfer with these 3 tiny bones, those 2 and that one. They are called the ossicles, and individually they're the hammer and the anvil and the stirrup. You can see it looks like a stirrup. Once the sound has been transferred by the stirrup, it goes to the fluid, which is inside the cochlea, which is this snail-shaped organ. The fluid vibrates and it causes little hairs inside the cochlea to wave up and down. The hairs are called cilia, and once the cilia are moving, they change the vibration into an electrical signal, and the electrical signal goes down the auditory nerve to the brain, where the brain interprets it as sound. Just for interest, these 3 shapes are called the semicircular canals. They're also filled with fluid, and they're designed to help the body stay in balance. You can see they're in 3 dimensions, vertical, horizontal, and the one in between, so it's like X, Y, and Z, and they're the things which help you keep balance.
Now, Year 7, I bet by now you'll never forget the parts of an ear. Now we're going to go on to measuring loudness. Loudness is measured in decibels. Try and remember how decibels is written. It's got a lowercase d and an uppercase b. So 50 to 65 decibels is the sound level of a normal conversation. But this guy's got, he's listening to a sound that's miles too loud. So it's probably around 80 decibels. And that can cause permanent damage if you listen to it over a long period of time. So anything 80 decibels or above, you need to be careful with. Please look at the PowerPoint so you can click through these links. This is about the sorts of soundness that can cause damage. So here's an example of a quiet whisper in a library. Could be 40 decibels. Classroom's a bit noisy at 60 decibels. But here from 80, like I said on the previous slide, permanent hearing damage can start to happen if you listen at this volume for long periods of time. And if you look, this is a sort of volume that your MP3 player or your phone can produce. And there's usually a little red line on your phone that says, loud sounds can cause hearing loss. You're sure you want to go here? And just be careful when you do. If it's a long period of time, you can cause damage. There's some other causes of hearing loss. Very simple one is wax blocking the ear. That's no problem because you can get something from the chemist that will loosen the earwax. If you have a sudden very loud noise, that can tear the eardrum, and the eardrum can sometimes grow back together, but then there's some scar tissue on the eardrum, so it never vibrates as well again. An ear infection can damage the eardrum. There's little bones inside. The hammer, anvil, and stirrup start to join together and start to fuse together, so they can't move as well. So they can't move the fluid in the cochlea as well. And loud noises can damage the cochlea. You might remember that that is the spiral organ which turns the sound waves into electricity. Now we're going to look at measuring pitch. So this is a slide from last lesson, and we just need to remember whether the pitch is high or low, stuff like that. So I'm going to leave you to think about these. So for this wave, the pitch is high or low. Which one is it? And the wavelength is something. And for this wave, the pitch is high or low. Just choose the right one. And the wavelength is something. Think about that. Try and answer it. Okay, now we come to measuring them. And we need to talk about the frequencies. We've looked at the wavelength for this wave. But now we're going to look at frequencies. So high-pitched sounds have high frequencies. The particles vibrate faster. That means in this transverse wave, the particles are going up and down quite quickly. So that's a high frequency. In this wave, this is a low-pitched sound, and it has low frequencies. The particles vibrate slower. So they're going to go up and down because it's a transverse wave much more slowly. Okay, so that's a low frequency. And the unit for frequency is hertz. It was named after this chap Heinrich Hertz, and it means cycles per second. In this animation down here, you can see this button flashes at 0.5 hertz, half a hertz. So that's one cycle every 2 cycles in a second. So have a look at the speed of that one flashing. And here at the bottom, this one's a bit faster because the frequency is 2 hertz. And you can see it's flashing a little bit faster than the top one. So that gives you an idea of how fast hertz are. And just a little point that in science, we use uppercase for a person's name, that's Mr. Hertz. And we also use it for the symbol, that's why it's uppercase H, lowercase z. But when we use the word for the unit, then we use the whole thing's lowercase. So have a look here, I've done that. The lowest sound a human, this is about the range in which humans can hear, from the lowest to the highest. The auditory range it's called. So the lowest sound a human ear can hear, even, is about 20 hertz. See, I've written it lowercase. And the highest sound a teenager can hear is about 20,000 hertz. I'm mentioning teenager because once you get older than about 20 or 25 maybe, the high frequencies start to decline. And when you get to my age, it's gone down to about 13,000 hertz. It's the same for everyone. So 20 hertz, the lowest here sound, 20,000 hertz for you, 13,000 hertz for me. Now we're going to look at how a loudspeaker works, because a loudspeaker converts electrical signals into sound waves. So here's an electrical signal. You can see it's changing up and down all the time. It changes with the waves, with the wavelength. And then this electrical signal flows around the coil of wire, which is part C. And part B is a magnet. And the coil of wire you can see moving in and out of the magnet. And that causes this cone to move. And the cone then causes the air to move. So the cone causes those compressions and rarefactions in the air. I'd like you to, when you go through the PowerPoint, I'd really like you to click on this link, because towards the bottom of this page there's a really excellent animation of how sound works. All the stuff that we've learned is in one animation. It's really worth looking at. For those people who've done sound before, especially, here's a little extension task for you to do, and that's to investigate how a microphone works and then to compare it with a loudspeaker. So that will take you half a page to explain, with a bit of help from Wikipedia and Google. And that completes lesson 3. So it says make sure you've watched the videos, make sure you complete the worksheet or worksheets, and please go through the PowerPoint and click on all the links. I hope you enjoy this lesson on sound, and I look forward to making a lesson number 4 on sound, which will end with the cavoot as normal.